I'm going to use the compound angle formula again here, because you can see we've got sine x plus y. We're going to use that to solve this expression here, or rewrite this expression, given that we know sine of x's value and cos of y's value. And you can see here that for sine of x, x is the angle, okay, so think of this as a theta. X is in a particular domain, and for cos of y, y is in a particular domain. Okay, so looking at the sine of x just to start with, what I'm thinking with this too, it's always a good idea, as soon as you see a particular domain, think about what this tells you. So for sine of x, we've got 0.2. X is in this region here, between 0 and pi on 2. So positive for sine and positive for cos in that region. Okay, so what that tells us is that for this angle x that we're dealing with, sine and cos are going to be positive. So that helps us with the branches we're going to work with. Same for this other expression here. We've got cos of y, this is our other angle y, equals negative 0.4, and we're in the region from pi to 3 pi on 2. So I'm always thinking about unit circle. I should really draw my unit circle in there. And what region we're in. So pi to 3 pi on 2 is this region here. So for that region, for y that we're dealing with here is this angle, we know that sine is going to be negative because it's down, and cos is going to be negative, and that makes sense because the cos we have already is negative here. The sine we have for x is positive. So keep these in mind as you're answering the questions. Okay, so let's start working. So for sine x 0.2, we need sine of x plus y. Now as soon as I see this, I think, okay, we're going to need to write out our compound angle formula. So sine of x plus y, remember the nice way to remember sine is that sine has the mixed angles. So it's going to have sine x cos y, the sine we'll talk about in a second in between, and then cos x sine y. So the angles are mixed up with the sine and cos. Now with sine, the sine that's actually in the middle here is going to be the same as the sine that's here. Okay, it's opposite with cos. So for us, we're going to put plus there. So that's the rule we're going to use. You can see that we need a few things. We have sine x, we have cos y. We don't have cos x and sine y. So let's find those. Now the easiest way to do that is to use our expression, the Pythagorean identity, cos squared x equals 1. And it applies as well to y too. So it doesn't matter what's in there for the angle for x or y. Let's use those. So let's use it first for sine x. So for cos, it's going to help us to find cos of x. We know sine of x is 0.2, so let's put 0.2 in there, squared, plus cosine squared x equals 1. Now you can put this into your calculator to solve, but we'll just re-express it. 1 minus, that's going to be 0.4, okay? So depending on whichever way that you want to do it, but we'll just put it in here, squared. And then cos of x equals, it's going to be plus or minus the square root, but because we know from here that cos of x has to be positive, it's going to be the plus square root of this answer here. Okay, so put that into your calculator. This is actually the square root of 0.96, okay, and you can get that as an approximate answer, but for the work we're doing here with trig, we want to make sure, and I'll put this in big capitals, that we are working exactly. Okay, unless it says something about decimal points, you want to keep everything exact. So this is a really important step here. When you have this answer, rather than putting it in your calculator to see the value, think about what this is actually saying to you. This is 96 hundredths, okay? Because think of this as a percent, it's 96%, 0.96. So as a square root, this is the square root of 96 hundredths. That is what 0.96 is, 96 out of 100. Now to keep this exact, we can use the nice rule, and I'll put this here, since, I'll just get rid of that, the square root, of a over b equals the square root of a on the square root of b. We can split this up. So we're going to have the square root of 96 over the square root of 100. Now the square root of 96 actually splits up really nicely into 16 times 6. You can get this anyway with your calculator. We'll simplify the third. And the square root of 100 is 10. Splitting this out, square root of 16 is 4 out the front, 4 root 6 on 10. And then cancelling, divide top and bottom by 2. It's a 2, that's a 5. So 2 root 6 on 5. So that tells us that cos of x is 2 root 6 over 5. I'll put that in a box. That's my first important bit of information. Goes with this one. So the next one, we're going to find, we know what cos of y is. Oops, excuse me. A bit nicer. So we're going to find sine of y. And we're going to use the same method for this. So we're going to use this expression now here. So sine squared y, I don't know, that's what I'm trying to find. Cos squared y, I know that cos of y is 0.4. So I've got sine squared y plus negative 0.4 squared equals 1. Okay, we know that negative 0.4 squared is going to be positive 0.4 squared, because when you square a negative it becomes positive. So I'll take it to the other side. This is just positive 0.4 squared and I've taken it to the other side. That's why it's a negative, okay, because this really doesn't need to be here. And what we're going to do then is solve. Now sine of y equals normally plus or minus the square root of what's in this bracket here. But because of our work over here with the quadrant and with the region of values here, we know that the sign is going to be negative because cos is. So putting that in, what you're going to end up with, if you figure out what's underneath the square root there, you're going to get 0.84. Okay, and again, I'll do this in light blue. We want to keep this exact. So stop the video here if you want to have a go at getting this exact yourself. Okay, 84 hundredths, which is the same as negative square root of 84 over the square root of 100, which is the same as, now square root of 84 actually turns into a nice thing, 4 times 24, because you can tell, oops, that 4 goes into 84 21 times, okay, and the square root of 100 is 10. And so to finish that off, we're going to have, give myself a bit more room, oops, negative 2, so square root of 4 is 2, root 21 over 10, and again cancelling, dividing the top and the bottom by 2, I'm going to end up with negative root 21 over 5. So I'll give myself a bit more room, do this over here. So what we end up with, we find that sine of y equals, in exact form, negative root 21 over 5. Now we've got all the pieces that we need, cos x, sine y, cos y and sine x, to actually find what we wanted, which is sine of x plus y equals. So let's put everything in. Sine of x is 0.2 times cos of y, which is negative 0.4, plus cos of x, 2 root 6 over 5, times sine of y, which is negative root 21 over 5. Okay, let's have a look here. This first part here is going to turn into negative 0.08. The next part is going to be negative because of the negative sign. It's going to be 2 times square root of 6 times 21, because the square roots multiply together, the whole numbers multiply together, and 5 times 5 is 25. Okay, and again looking at that, this here actually looks quite ugly, but what this turns into is really pretty, or really nice I should say. So inside that square root you're going to get 126, okay, when you do that, and although that doesn't look nice, again I'll just erase this part here. So to finish it off, just having a look at this again, we've got negative 0.08. I'm going to use that trick of writing that as an exact form. So this is 8 100ths, 8 hundredths, so 8 over 100, minus, what's inside the square root actually is 9 times 14. Now as a trick for these, if you can't figure out what this would simplify to, try your perfect squares. Go through 4, 9, 16, 25, 36. Do they divide into this number? Okay. The nice thing with this is that you only have to go to half this number to figure out if any of those squares go in. So if you figure out what half of 126 is, do all the perfect squares underneath that. Do they all go in? If they don't, then this is not going to be able to be divided by perfect square. So this turns out, I'm just going to do a bit of simplifying here. So 8, if we divide the top and the bottom by 4, So 4 goes into 8 2 times, 4 goes into 125 times. This is negative 2 over 25, okay, here. And this is going to be negative 2 times the square root of 9 is 3. So 2 times 3, which is 6, root 14 over 25. And to simplify, just to finish it off, I'll get rid of this part. It's a good idea to put everything that you can factored out the front. Okay, so you can see what's in common here is the 2 and the 25, and also the negatives. So let's factor those out the front. Negative 2 over 25 outside of, okay, 1, because this is one lot of negative 2 over 25, plus, because the negative is out the front, and we have 3 root 14 left over in the bracket. Now that's the answer in your textbook. If you use your CAS, and watch the CAS video after this one's a quick video of how to just do all of this really, really quickly using your TI, you'll actually find that your answer is in the expanded form. It looks like this. All right, so if you're confused when you look at that answer, it's just in that expanded form. So using your compound angle formula and taking care with your domains before you work to get the answer for the expression for sine of x plus y.